let us look at this example of resistor color code. Now, just a reminder, you'll generally find resistors with 4 colors or 5 colors. Those with 4 colors, they call them 4 band. Colors 1, 2, 3, and then 4. 5 colors, you have 1, 2, 3, 4, and then 5. Now, you will see that of the resistors with 4 colors, 3 of them are close together, and then 1 color is further apart by itself. That 1 color it represents a tolerance. If you read from left to right, you would read first the group of colors that are close together. You have the first and second color will be the first and second digit. Then the third color, the multiplier, and the tolerance to its right. With those that are 5 color or 5 band, you have the 4 grouped together, close together, and then the 5th one far away from them by itself. So you start reading first, second, and third digits. The 4th will represent the multiplier, and then the 5th, the tolerance. So the 5th color is always the tolerance. The color to its left is always the multiplier. Then the remaining color as you go left will be the digits. Alright? Or reading from right to left. The second to last color is, reading from left to right. The second to last color that you see will be the multiplier, and the last color is the tolerance. But the colors before them will be the digits, represent the digits. Alright, so let's look at this example. We have a 4 band resistor. Those 3 colors that are close together, you have them here, orange, black, and brown. Then the color by itself at the other end is silver. So let's see. You know that the second to last color, in this case the brown, is going to be the multiplier. The colors to its left will be the digits. So orange, you look at the table, what color is associated, what number is associated with orange? It is 3. So for orange we have 3. Black, let's see which number is associated with black. It's 0. 3, 0. The second to last color, the tolerance. So the multiplier. So it means multiplied by 10 raised to the power of. You look at what number is associated with brown. That's 1. So as you see in the multiplier section, it's 10 to the 1. So it's multiplied by 10 to the 1. Then the silver is the tolerance. Let's see which is the tolerance. Plus or minus 10%. So it is plus or minus 10%. Alright. Now what is the resistance of this resistor? It is 30 multiplied by 10 to the 1. 10 to the power of 1 is 10. Plus or minus 10%. So 30 multiplied by 10 is 300, plus or minus 10%, which is 10%, 10%. 10 per 100, 10 over 100. Alright? Now, for this 10%, it means that you found the 300 and you will find 10% of 300. 10% of 300 is equal to 10 divided by 100 multiplied by 300. And what is that number? 10% of 300 is 30. So what you are talking about here is 300 plus or minus 30. Now, the average resistance is 300. But in manufacturing, they can't make it exactly 300 ohms. And they are mass produced, making a large number of them every day. So, there is a certain standard that requires them to make these resistors so that the resistance is not more than 10% above 300 and not less than 10% below 300. So the highest value you should expect what is the highest value? It is 300 plus 30. You know what? It's measured in ohms, alright? I'm going to put the omega sign after. So the highest value should be 300 plus 30, which is 330 ohms, omega, alright? What is the lowest value it should be? It is 300 minus 30 ohms. 300 ohms minus 30 ohms, which is 270 ohms. So here, the average resistance is 300 ohms, but it could be as low as 270 ohms, or it could be as high as 330 ohms.